You've been memorizing physics equations for weeks, right? But if you're still dropping marks on calculation questions, the problem isn't your math. It's a trap hidden right in the numbers. We are skipping the fluff today and jumping straight into a high-stakes exam survival guide. This is your final minute upgrade to turn your Cambridge Physics 0625 revision into a literal scoring system. Let's lock in those top band marks.
Imagine this for a second. You're sitting in the exam hall, the clock is ticking down, and you confidently calculate an area. You write down your final answer, feeling great about it. But when results day comes around, you see you've lost top band marks. Why? Well, just because you calculated that area using a length of 20 centimeters and a width of 10 millimeters, and you multiply them together without converting them first. It sounds incredibly simple, doesn't it? Yet, this is literally the #1 silent killer of grades.
And this is exactly why ordinary passive revision fails you. Just staring at formulas, not going to cut it. If you ignore the unit traps buried inside Cambridge command words, your entire scientific reasoning just collapses. Look at this comparison. The flawed calculation of 200 completely ignores the units. It's just numbers mashed together. The correct approach, however, demands consistent units before you even reach for your calculator.
Okay, let's dive into this by securing our first quick win. You've got to lock in these basic SI units from this table so we can easily compare the size of variables. Length is in meters, mass in kilograms, and time in seconds. Instantly recognizing these symbols, m, kilogram, and s, is your absolute first line of defense against an examiner's tricks.
Now, here's where it gets really interesting. Look at these alternative units. Examiners love, and I mean absolutely love, throwing kilometers, millimeters, or hours into the mix. These aren't typos. They're specifically designed to test your situational awareness under pressure. They want to see if you'll blindly plug a time given in hours into a formula that actually expects seconds.
Which brings us to derived units. Think of a derived unit as something based on a calculation, like meters per second for speed. When you're calculating speed, if you carelessly mix up distance in meters and time in seconds with distances in kilometers and times in hours, well, your derived unit is going to be completely, hopelessly wrong. It'll just be a meaningless number. You literally cannot have a speed in meters per hour if the mark scheme is hunting for standard SI derived units.
Building right on that foundation, here are the essential SI units you absolutely must recognize on site to fulfill those tricky command word requirements. Force is newtons, energy is joules, power is watts, and so on. If the question asks you to calculate the power output and you confidently write down your answer in joules, you're demonstrating a fundamental misunderstanding of the concept to the examiner, even if your math is 100% flawless.
So, converting a basic length is pretty straightforward, right? But ask yourself this: what is the massive examiner clue you are completely missing when converting volume? In a moment, I'll show you the exact examiner clue that changes the answer completely. But first, you need the framework that makes that clue incredibly obvious.
Okay, here's that framework. It's the consistency rule. Honestly, this is your golden rule for this entire explainer. In any single calculation, the units you use must perfectly match one another. If you're calculating an area using length and width, they must, no exceptions, be in the exact same unit system before you even think about multiplying them.
And this perfectly illustrates the concept straight from the source material. Look at this. You have a length of 20 centimeters, but a width of 10 millimeters. The absolute, non-negotiable first step is converting that 10 millimeter width into 1 centimeter. Only then can you actually run the calculation. 20 centimeters times 1 centimeter equals 20 square centimeters. Visually simple? Sure. Operationally vital? Absolutely.
But now let's escalate the stakes. Here is the boss-level trap that catches out even top-tier students every single year. Scaling up from a linear length to an area and then to a volume actually requires you to square or cube the conversion factor. We all know 1 meter is 100 centimeters. That's basic. But 1 square meter is not 100 square centimeters. It's 100 squared, which is 10,000. And for volume?
That's right. To convert from cubic centimeters to cubic meters, you don't divide by 100. You divide by 1 million. And this right here is exactly where most students drop zeros, their decimal places shift wildly, and they lose heavy, heavy marks on those big 5-mark calculation questions.
So I highly recommend you basically memorize this framework right now. Take a mental snapshot of these exact conversions. Applying this specific process, knowing exactly when to divide by 100, 10,000, or 1 million turns a complicated, panic-inducing exam calculation into guaranteed method marks. Look, even if you mess up the final addition somewhere, showing the examiner you logically know how to convert these units secures you points.
All right, it is time for a quick, interactive viewer challenge. I want you to pause this explainer right now and predict the common error hidden in this Cambridge-style practical investigation question. You need to calculate the volume of a block with a length of 50 centimeters, a width of 50 centimeters, and a height of 50 millimeters. Spot the trap? Okay, if you guessed that the student just carelessly multiplied the numbers together, you hit the nail right on the head. The flawed student answer rushes the data directly into the equation without checking unit consistency first. They do 50 times 50 times 50, get 125,000, slap a cubic centimeter symbol on the end, and just move on. The result? 0 marks. A totally invalid conclusion because that height was stuck in millimeters?
Now let's break down the improved top band answer. This student applies our exact framework. First, they grasp the concept of the volume equation. Next, they spot the evidence of the mismatched unit, that sneaky 50 millimeters. Then, they apply scientific reasoning to convert it to 5 centimeters. And finally, they present the calculation. 50 times 50 times 5 equals 12,500 cubic centimeters. Safe, precise, and full marks awarded from the examiner.
To recap this whole system, always run this final practical check before you finalize your answer. Check that your apparatus and variable measurements actually match in their units. Always convert before calculating area or volume, never after. Write your derived unit symbols clearly, and please, double-check your zeros when scaling up to square or cubic meters. You want your significant figures, units, and reasoning to be perfectly aligned. So you've mastered unit conversions. You now know that a single millimeter can literally destroy an entire calculation. But ask yourself this: what happens when the measurements themselves carry hidden uncertainties and anomalies? Leaving a graph scale error or failing to spot a practical anomaly is the next massive trap just waiting to destroy your grade boundary.
You absolutely do not want to walk into that exam without knowing how to handle those graphical anomalies. This is your mandatory next step, a full revision map and past paper walkthrough. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations, and click the explainer on screen right now to master the final uncertainty framework and secure those top grades. I'll see you over there.